Hello everyone, welcome to our channel. In today's video, we are diving into Interview Ready, Learn DBMS Fundamentals. Your quick guide to learn DBMS concepts and cracking interview questions with confidence. Let's get started. What is DBMS? A DBMS, Database Management System, is a software system that enables users to define, create, maintain, and control access to databases. It provides an interface between the user and the database for managing data efficiently and securely. What are the key components of DBMS? Database engine, core service that handles data storage, retrieval, and manipulation. Database schema, structure that defines tables, fields, data types, constraints, and relationships. Query processor, interprets and executes database queries, usually written in SQL. Transaction manager, ensures that all database transactions follow ACID properties. Concurrency control manager, handles simultaneous data access to prevent conflicts or data corruption. Storage manager, manages how data is stored on disk and in memory, including indexing and data access paths. Buffer manager, manages in-memory data buffers for faster access and performance optimization. Authorization and authentication manager, manages user roles, privileges, and ensures only authorized access to data. Recovery manager, provides tools and processes for backing up data and recovering it after failures or crash. What are the functions of a DBMS? Data storage management, efficiently stores large amounts of data. Data retrieval, allows users to query the database using languages like SQL. Data manipulation, supports operations like insert, update, delete. Transaction management, maintains data integrity in multi-user environments. Concurrency control, handles simultaneous data access. Backup and recovery, provides mechanisms for data backup and recovery after failures. Security management, controls access using user roles and privileges. What are the advantages of DBMS? Eliminates data redundancy and inconsistency. Provides data sharing among multiple users. Ensures data integrity and accuracy. Offers backup and recovery options. Enforces security through controlled access. Supports data independence. What is a checkpoint in DBMS? A checkpoint in DBMS is a mechanism used to minimize recovery time during a system crash or failure. It acts like a snapshot of the database at a particular moment. The checkpoint ensures that all changes up to that point are saved to the disk, so the system doesn't have to reprocess all transactions from the beginning during recovery. Checkpoint is important because it helps in reducing the amount of work needed during recovery. It ensures data consistency and avoids redoing already completed transactions. It allows the system to restart quickly and safely after a crash. Example, imagine a banking app where many transactions are happening. A checkpoint is created every 5 minutes. If the app crashes at 11:07 and the last checkpoint was at 11:05, only transactions between 11:05 to 11:07 need to be recovered. All transactions before 11:05 are already saved. What do you mean by transparent DBMS? A transparent DBMS refers to a database management system that hides internal complexities from the user, providing a simplified and consistent view of data regardless of how or where it is stored. In simple terms, it makes the database operations appear seamless or invisible to users and applications. They don't need to worry about how the data is stored, retrieved, or maintained. Example, think of online banking apps. You just check your balance or transfer money. You don't know which server holds your account, how it handles backups, or where your transaction gets processed. All that complexity is hidden. That's transparency in action. Explain types of transparency in DBMS. Location transparency, users don't need to know the physical location of the data. Replication transparency, users are unaware of data replication, copies of data for reliability, performance. The DBMS ensures consistency and load balancing automatically. Failure transparency, the system can recover from failures without user intervention or awareness. Concurrency transparency, multiple users can access the database simultaneously without interference. The DBMS handles locking, transactions, and isolation behind the scenes. Fragmentation transparency, data may be split, fragmented, and stored in pieces across various locations. Users see and access it as one unified dataset. Access transparency, different ways of accessing the database, e.g., SQL, GUI, API, are managed by the DBMS. Users get a consistent experience no matter how they access it. What are the different types of DBMS? Hierarchical DBMS organizes data in a tree-like structure with parent-child relationships. Example, XML data storage, IBM's IMS, information management system. Network DBMS allows many-to-many relationships using a graph-like structure. Example, integrated data store, IDs, Turbo IMage. Relational DBMS, RDBMS, stores data in tables with rows and columns, using SQL for operations. Example, mysql, postgresql, oracle, SQL server. Object-oriented DBMS, OODBMS, stores data as objects, integrating database and object-oriented programming concepts. Example, DB4O, Object DB. NoSQL DBMS manages unstructured or semi-structured data using models like document, key value, column, or graph. Example, MongoDB, document, Redis, key value, Cassandra, column, Neo4j, graph. What is data abstraction in DBMS? Data abstraction in DBMS refers to the hiding of complex details of how data is stored and maintained, and showing only the necessary parts to the users. It helps in simplifying database interactions by separating data into different levels of abstraction. Levels of data abstraction. 1. Physical level, lowest level, describes how data is stored in memory, hard disks, indexes, storage blocks. Concerned with storage format, file structures, compression. 2. Logical level, middle level, describes what data is stored in the database and what relationships exist among them. It hides physical storage details. 3. View level, highest level, closest to end users. Describes only part of the database relevant to a particular user. Provides custom views, security, simplicity. What is intention and extension in DBMS? Intention, schema. Intention refers to the structure or blueprint of the database. It defines the schema, including tables, columns, data types, constraints. Extension, state. Extension refers to the actual data stored in the database at a particular point in time. It encompasses rows, tuples, current data. Summary. Intention defines the structure, schema of the database. Extension represents the current data, state within that structure. Thanks for watching. I hope you found the video helpful. If you liked it, don't forget to give it a thumbs up and subscribe to the channel for more interview-ready content.